So, next day, and sometimes it's not a bad thing to stop and do something else, because I had an idea how to determine where we are with the bent shaft. So what we know now is we're skimming the top when we rotate the boring head. So what we're going to do, we rotate the engine crankshaft by 180 degrees down here, and then we figure out the distance between the boring, between the tool and the shaft. Either we hit it or we don't. If we don't, we measure the gap and then we tip the engine until the gap is equal on both sides. So we know we are perfectly in center, because it was almost impossible to center the end of the shaft because it's bent. But now this surface is known, it's center on the machine, so we know this part is center, but we couldn't center the outer end, basically this end. We don't know where we are. We can be up in the air or down, we don't know. So what we're going to do, we just retract that, and then we rotate the engine by 180, and we get a mark down there. We roughly know where we are. So now rotate our boring head. So I can't really see it. It looks like there is a gap. I just don't want to trash my tool. We'll come back when we said. Okay, we got everything we need. We just use a piece of paper and just wind. We got a fair amount of clearance here. So, and we are definitely on the skimmed part. Mark is here. So all we need to do is, using a feeler gauge, and see if it gets in or not. That's a 0.3. We still have clearance. So I reckon it's about 0.5. Just from the feel. 0.6 doesn't fit, so we're probably in the region of 0.5. So we need to come down 0.25 millimeters, I think. 3, where's the 4, 5. Yeah, 5 hardly fits. So we're somewhere between 0.4 and 0.5, I think. Where's the 4? It's always the last one, is it? 0.4, here we go. And it just fits. So we need to come down. Again, what we did was a relatively simple process. We skimmed the outside. This was top before. We skimmed it, so the tool was touching, so we know we're hitting it, and now we turned it down and we got a gap of 0.4 millimeters, say. That means we are 0.2 too high, because we should have skimmed, in relation to this one, we should have skimmed 0.2 millimeters less, because even the shaft is bent, we're still too high. So what we're gonna do, we put an indicator on and just get that down by that level, and then we turn it around and check it. So what we're gonna do is actually just move the tool where the keyway is, so I can go in and out. Let me set that indicator and then we'll come back. So we use a digital indicator, and all we need to do is actually cranking that down by 0.2 millimeters. 200s. 5. Make sure we're not going to hit anything here. So I'll leave it on 0.18 because it barely fitted. So we're now on minus 0.18 millimeters. Our total runout, which we measured to the machine surface, was 0.4, just under 0.4. The 0.4 feeler gauge was hard to get in, so that's the reason why I set it to 0.18. So that's 0.36. I think that's about the right thing. So now we're going to confirm that. We get the tool back to the bottom, measure the distance with a feeler gauge again, and then we turn the crankshaft around, measure at the top, and if the distance is equal, we should be fine in that direction. Hope that's fairly understandable, but it's, in my opinion, it's the only process which works with that badly bent shaft here. So once I've done that, I'm going to reset the tool and just carry on skimming. Alright, let's remove the indicator and double check it, and then we'll come back. So it looks good. We're cutting a fairly equal amount around the shaft now, so we just carry on doing that. I advanced the boring head by about 0.2 millimeters, 0.15 millimeters, and I was just checking how it actually works all the way around. So there's obviously a lot of flex in the tool, so you can only take very light cuts, and probably need to do a few spring cuts just to make it round all the way, because where it hits the keyway it's very likely you got some sort of bump. So just 2, 3 or 4 spring cuts and that should be fine. And now we're coming towards our old. I go very slow and I feed by hand, because with the power feed I probably can't stop quick enough because the lever is on the other side. So I'd rather do that by hand. If someone moves, I can still stop the whole thing, sort of. Now we're cutting here. Yeah, and we're gonna do that all the way down to the end, and we'll see what we get. Once we've done that, we indicate the shaft of the engine against the mill again, just rotate it, and make sure we're 100% round, or no, let's say 100% centered, because we still don't know for sure if what we're doing here is exactly on center to the engine, because the shaft was so bent. So it's pretty hard to determine where we actually are. But by the look at the cut, it looks quite good actually. So now we're hitting that ridge from the keyway. Actually this one here, that's a bit of a ridge here, so that hammers the tool a bit. Yeah. Not much we can do about. So let's cut that down to the end and then we'll come back. So we did one pass. I don't know if that's visible on camera, but we're a bit shy in this area. So the clonking pulley shaft or pulley sleeve was hammering on this end, and that's exactly what I measured before. The shaft, I need to get out of the way here. The shaft was thinner at this end rather than on this end, and that's exactly what we can see. It's almost like a dent here. It worked out a lot of material here. he was cutting here all the way. Just in this area there's no cut at all. So we need to do another pass with probably about 0.1. I'm just going to check what the actual diameter is. Yeah, we just under 25, and it's pretty consistent, so I'm quite happy with it. We are between 2 and 300 of a millimeter below 25 millimeters, and in both directions, which is good. So we're on center. That was my biggest worry, that we're not on center. But if the diameter measured here and here is the same, we should be on center. That, I don't know how much that is. Let's figure out how much that is. Yeah, that's 24.93, so we need at least another 500 or so to get that cleaned up, because all the rest is all clean. That spot here, which is smaller, which makes sense because the keyway was hammered here. Okay, so it seems the plan is working. Alright, let's do another pass and come back then. So we ground the tool down here so it doesn't rub anymore. We put an indicator on and we're just gonna I think we go that's 400 in radius, so it's 800 in diameter. It's 0.08 millimeters. Alright. That's barely touching. I had the tool out, so I may need to do a little bit more, because it was rubbing on the big part of the tool. So at the very end it's a bit thicker, so I'm just gonna skim that down and then give it another try and see what it does. Yeah, it's hitting now at the end. And now we're cutting. Before we didn't cut because the big part of the tool was rubbing. Now it looks better. Okay. So we need another 400 or so. Just by loosening it comes up a little bit. So it should be exactly 0.1 millimeter in diameter. Cooking with it. cutting at least something here. So I want to take off the shaft as little as possible. As soon as the thing is around, I stop and I'll just make the bushing to size. I think we need another pass here. I'm not gonna catch that. But my quote for such project is, doesn't matter if it takes half an hour longer, because you got only one try. Cutting a little bit, but it's still not enough. So at least we need at least another 100. What I can see here. A little bit of play in the mill, not much. I can hear it. For a 52-year-old machine, I'm pretty happy with that thing here. Still pretty accurate. Okay. So we're still a bit shy here. Looks like, I think that's at least 100, 150, 100. So surface finish, let's say it's acceptable. But that long boring bar, it's pretty good actually. So let's cut that down to get rid of that one, and we're probably ending up with 24.8 or so shaft diameter. Should be still okay. I was hoping for 25, but there's no way. It's so much wear on this shaft. Alright, we'll come back when we got a clean shaft. So we did the second pass, and it's still a bit shy here. It's a little rich. I don't know how much it is and how deep it is. I'm on 24.78 or something like that. I changed speed as well. It gives me a little bit of better surface finish here. So let's give it another go. That's about 700 RPM now, and you can see the surface finish looks a lot better. That interrupted cut doesn't really help with that keyway, but there's nothing I can do about that. I checked it in various places, and the resulting diameter looks good. It's probably 100 of a millimeter off or something like that, so pretty happy with that. At the end, it's not a super precision machine, it's a lawn mower. As long as the shaft is fairly straight and the pulley doesn't wobble anymore, I'm pretty happy with that. Let's cut that to the end because it's going to be boring. I'm feeding relatively slow, so I'll come back when it's done. So we're done with the cutting. I think I do a couple of spring passes because the surface is a bit uneven, because the feed, it was hand fed, so it was not super precise, but I'm pretty happy with the result. I can't see any weak spots anymore, so it appears to be round. There's no fails anymore, so let's check the diameter. That is 74, 76, 77, 74, 74, 74. $75. So I think we got a variation of about plus minus 0.02 of a millimeter, which is not too bad. I think I'm going to do another spring pass, and then we'll see where we're at. But I think we're pretty good. The average is about 74, so 29.74 millimeters. I don't want to cut any more off really. I just do a couple of spring passes and then we call it done. Then we turn the engine around and mill the keyway to a reasonable size, either 7 or 8 millimeters. But by the look at it, it's going to be 8, I think. There's a lot of material missing here. We'll see. Let's do a couple of spring passes and then a few more measurements, and then I think we should be good to go. Well, I think we can call it a success. I did about 4 or 5 spring passes and that eased it out. I'm between 24.68 and 24.69. I've measured it in about 10 different positions here, everywhere, and the deviation is about 100 of a millimeter, which is absolutely fine because I think that's well beyond the accuracy of the machine here. I was only cutting inwards, not outwards, because I think the table is tilting a little bit when I change direction, so I was doing all the spring passes inwards, and that made it certainly better. Otherwise it was cutting too much on the outside, which indicates the machine is tilting. But if you look at the whole setup here, even the machine is quite rigid. It's a lot of lever here, and the engine is hanging towards, the whole weight of the engine is hanging towards this end as well, so I'm pretty happy with the outcome. We have a straight shaft which has almost the same diameter at any place, which was a challenge to indicate because the thing was just so bent, and I couldn't see any flat spots, any weak spots anymore, so we call that good, and we just make the sleeve to the size, whatever it is. Next job will be the keyway. We need to cut the keyway straight because it's considerably worn here, so I will turn the engine around and just use an 8mm end mill. Obviously lock the crankshaft in the right position and then just go through, and the engine should be done. Well, that's a bit of a relief. I was still worried that we might have some offset here, but it turned out it was just about perfect. Again, that mill is not the newest one, so we need to do a little bit of chamfer, but I'm going to do that with a file. You can feel there is still a bit of, yeah, it's machined. It's a machine surface. I upped the speed again, so I was on top speed actually, which is about 1300 RPM. Looks pretty fast, but for the last skim, and that took off a little bit more and made it a relatively nice, acceptable surface. So I think it's dinner time. We call it a day. And gonna do the keyway tomorrow. Thanks for watching so far, and stay tuned for the rest of it.